So this topic, or today's topic, is related to the periodic table and arrangement of elements on the basis of atomic number, and that you just have to learn for first 20 elements, and you don't have to memorize in exam. You will have the periodic table, but it's better if you memorize the first 20 element, so you can quickly do the questions related to this topic. So first thing, the elements are arranged on the basis of atomic number, or we can also say proton number. So in a periodic table, what is the arrangement of the elements? The elements are arranged on the basis of proton number, and you can see the proton number. Yes, the periodic table will be there available. You don't have to memorize. They will provide you the periodic table, and this is actual periodic table from the exam. What you will see in the exam, the same periodic table. So elements are arranged on the basis of atomic number, proton number. You can see hydrogen is 1, then helium is 2, lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen is 7, oxygen is 8, fluorine is 9, neon is 10, sodium is 11, magnesium is 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, and calcium 20. So these elements are arranged Five is boron. So as you can clearly see, these elements are arranged on the basis of proton number or atomic number, and so on. 21 scandium, 22 titanium, 23 vanadium, 24 chromium, 25 manganese, 26 iron, 27 cobalt, 28 nickel, 29 copper, zinc 30, gallium 31, germanium 32, arsenic 33, selenium 34, bromine 35, krypton 36. But the first 20 elements are important, so you should know the first 20 elements. And what this top number is representing, as we discussed in the last class, this top number is representing the atomic number, or you can also say proton number. And the bottom is representing what this number is representing. This is representing atomic mass, or you can also say nucleon number, or you can say the sum of proton and neutron. So bottom number is representing the sum of neutron and proton, whereas top number is representing the proton number. And the elements are arranged in a periodic table on the basis of proton number. So for example, for hydrogen it is written 1. So how many protons are there in hydrogen? If atomic number or top number is written 1, so how many? This number is representing a proton number. So how many protons are there in hydrogen? Hydrogen will have 1 proton. Then helium, for helium it is written 2. So how many protons are there in helium 2? For lithium it is written 3. So it has 3 protons. Beryllium is having 4 protons. Boron having 5. Carbon is having 6 protons. Nitrogen 7 protons. Oxygen 8 proton. Fluorine 9 proton. Neon 10 protons. Sodium 11 protons. Magnesium 12. Aluminium 13 protons. Silicon 14. Phosphorus 15. Sulfur 16. Chlorine 17. Argon 18. Potassium 19, and calcium 20. So this top number is representing the proton number. And what this bottom number is representing, it is representing the atomic mass or nucleon number, or we can also say sum of proton and neutron. So when you add the total number of proton and neutron, you will get that as the mass number or nucleon number. So for hydrogen, when you check hydrogen, the symbol for hydrogen, it is written 1 1. So in case of hydrogen, it is written 1 1. So what is atomic number here, the top number? So atomic number is 1. What is atomic mass or mass number, or you can also say nucleon number? That is also 1. So atomic number is represented by Z and atomic mass is represented by A. If we want number of protons, so the total number of protons given by Z, so that is equals to 1. If we want number of neutrons, that we already did in the last session, so that is A minus Z, atomic mass minus atomic number, so it will be 1 minus 1, 0. And if we want number of electrons, because it is a neutral atom, so Z minus the charge. For a neutral atom, there is no charge, so number of proton and number of electron will be same. So when we draw the structure of hydrogen, so hydrogen is an element which contains one proton and one electron is revolving around this. So there is only proton inside the nucleus. Hydrogen does not have any neutron. Is it clear? The structure of the hydrogen and atomic number and atomic mass. Any doubt in this? Same way, when you check the periodic table, how to know the charge? If the any number is written, Abdullah Sarfraz, if it is written like +1 or -1, that is called the charge. If nothing is written, it means it does not have any charge, or it is having a charge 0. And whenever the charge is 0, nothing is written, it means that it should have equal number of protons and electrons. So elements which are shown in a periodic table or given in a periodic table, they are all neutral atoms, they don't have any charge. But when they lose or gain electron, then the charge will be there, and that will be given. Like example, if they write, it is written Al 3 plus or plus 3. So that 3 plus or plus 3 is representing a charge. So, but in a periodic table, when you are looking at the element in a periodic table, they don't have a charge. So when we check the second element in a periodic table, which is helium, so helium, it is written 2 and 4. So when we work out the structure of helium, helium is He, which is 2 and 4. So what is atomic mass here, or nucleon number, which is known as A? What is nucleon number in this example? So nucleon number is 4 here, or A is equals to 4. Then what is atomic number, or you can also say Z. Z or atomic number. What is atomic number in this example? So that's equal to 2. And if you want to find number of protons, the number of proton is same as atomic number, which is equals to Z. So as Z is equals to 2, the number of proton will be 2. The number of neutrons, that is equals to A minus Z, atomic number minus atomic mass, so 4 minus 2, that is equals to 2. And the number of electron, that is equals to Z minus the charge. But again, you can see here there is nothing written on this, so it means it has zero charge. There is no charge, so it will be Z, which is 2, minus the charge is 0, so that is 2. And because you have equal number of proton and electron, that is why there is no charge on this. When we draw the structure, so what we have, the center, we have 2 protons and 2 neutrons. So we have 2 protons and 2 neutrons in the center, and around the nucleus, the first shell maximum can have 2, and we have 2 electrons, so 2 electrons will revolve around the nucleus. So this is a structure of helium atom. Then the third element in the periodic table, when you check the third element in the periodic table, which one is the third element in the periodic table? As you can see the periodic table, the third element or element with proton number or atomic number 3. So that is lithium. So and lithium, it is written 3 and 7. So for lithium, it is written 3 and 7. So the nucleon number or atomic mass, or we can also say nucleon number, or we can say A, so that is equals to 7. And atomic number, that is equals to Z, so that is 3, that's right. And to get the number of protons, that is given by Z, so in this example it is 3. To get the number of electrons, number of neutrons first, so that is A minus Z, which is 7 minus 3 equal to 4. And to get the number of electrons, in this example there is no charge, so that is the for Z minus the charge, so Z is equals to 3 minus the charge is 0, so that is also 3. And for a neutral atom, the atom without a charge, it should have equal number of protons and electrons. When we draw the structure, so we have 3 protons. In the center we have 3 protons and 4 neutrons. Then we'll draw the first shell, but first shell maximum we can adjust 2. So we adjusted 2 electrons. Then we draw the second shell. The second shell maximum can have 8, but because we have to totally arrange 3 electrons, 2 of them are already arranged, so this will be the third electron. So this is the structure of lithium. Is it clear? Then in a periodic table, when you check the periodic table, we define the term groups and periods. So group refers to the vertical columns and what it represent, the group represent the number of electron in the last shell. Or number of electrons so how many electrons are there in the last shell, that will represent the group number. So when you check the groups, the vertical column, so the first one, this is group 1. I will use the shades here to represent. So the first, this shade is representing group 1. And this Roman number 1 you can see here, this is showing a group number. Then we have group 2. Group 3. Group 4. Then group 5. Group 6. Group 7. And group 8. So these are the 8 groups. So in a periodic table you will find 8 groups. What about these elements which we did not include in the group? As you can see in this part, if I shade this region as well. So what about these elements which we did not include in the group? What we call them as the elements in this region are known as the transition element, and they are not placed in a specific group. There is a reason for that. Same thing, transition element. So there is a reason why these elements are not placed in a specific group, but that is in the chapter 10 we'll discuss why transition elements are not placed in a specific group. And you can also see another element which is not placed in a specific group is hydrogen. Why hydrogen is not placed in a specific group? Because when elements are placed in a specific group, they have the similar property, similar chemical property. Like example, group 1 elements such as lithium, sodium, potassium, rubidium, cesium and francium. So these elements, they have the same chemical properties. When you move to group 2 will have a different properties than group 1, but the element in the same group will have similar properties. So properties of a beryllium matches with magnesium, magnesium matches with calcium, calcium matches with strontium, strontium matches with barium, and barium matches with radium. So they have the similar properties. But what about hydrogen? Why they did not place a hydrogen in any group? Because when we draw the structure, as we know, group represent the number of valence shell electron. So when we draw the structure of hydrogen, as we did, that hydrogen is having one proton and it is having one electron. So number of electron in the last shell, the total number of electrons in the last shell represent the group number. So according to this theory, hydrogen is having only one electron in the last shell. So number of electron in the last shell shows a group number. So hydrogen should be in group 1. But why they did not place hydrogen in a group 1? Because the properties of hydrogen does not matches with these elements. Hydrogen is a gas at room temperature. where all these metals are solid at room temperature. Chemical properties also does not matches with other element. That's why they did not specifically place hydrogen in group 1 and they keep it separate from all the other elements. Is it clear the concept of the group? So group is representing the number of electrons in the last shell. I'll give example as well, but in a periodic table you should be able to identify the groups. The vertical columns are known as a group. So this is group 1, 2. So group 1 and 2 are on the far left hand side. Then group 3, 4, 5, 6, 7 and 8 are on the right hand side. In between there are elements which are known as the transition element, which are not placed in any specific group, as well as hydrogen, because hydrogen properties does not matches with group 1. That's why it's not placed on group 1. It is placed separately in a periodic table. So how we can work out the group from the structure? So finding the group of element from the structure or electronic configuration. Example, you have element beryllium. When you check the periodic table, so when you check the periodic table, which group beryllium is present? What is the group number for beryllium? It is in group 2. This is directly we look at the periodic table and we identify beryllium is in group 2. But there is also another way to work out the group of the element, that is by the structure. So after drawing this structure, we can also work out the group of the element. So we know beryllium, it is written 4 and 9. So for beryllium Be, it is written 4 and 9. What is A here? Mass number or nucleon number? What is A here? The value of A. I want others to participate as well. So beryllium is 9, A is 9. What about Z here? So Z is equals to 4. If I work out the number of protons, when I work out the number of proton, so number of protons, that is given by Z. Number of the protons are given by Z, so that is equals to 4. The proton number is equals to the atomic number which is given by Z, the top number. The number of neutrons, that is equals to A minus Z. So equal to 9 minus 4, that is equals to 5. So there are 5 neutrons. And when I work out the number of electrons, that is Z minus the charge, because it does not have any charge, so Z is equals to 4, charge is 0, so that is equals to 4. So proton and electrons are same. When we draw the structure, It is having 4 protons, it is having 5 neutrons. I will draw the first shell. First shell maximum it will have 2 electrons. Then we draw the second shell. The second shell maximum it will have 8, but because we have to arrange only 4 electrons, 2 are already done, so remaining 2 we arranged. So this is the structure of beryllium. So using the structure, how we can work out the group number? As we know, the group number represents the number of electrons in the last shell. So as you can see, the number of electrons in the last shell, how many are there? There are 2 electrons, one, this is one and this is the second one. That's why it is group 2. And when we represent a group, we represent in Roman, so it is group 2. And when I write the electronic configuration, so using an electronic configuration, we can also work out the group number. So if I say electronic configuration is 2, 2, so this 2 is representing the group because that is the number of electrons in the last shell. Is it clear how we work out? So using a periodic table directly we can say the group number, but if structure is given we can also work out the group number. So if we know the structure, we can also work out the group number. So another element, we have magnesium, which is 12 and 24. So what is A here for magnesium? Abdullah Sarfraz, electronic configuration means how many electrons are arranged in each shell. So why it is written 2, 2? As we discussed in the last class, that first shell, how many electrons are there? 2. So I write 2. The second shell, then comma, then second shell, how many electrons are there? 2. So electronic configuration is 2, 2. Yes, the number of electron, Hatim, represent the total number of electron in the last shell always represent the group of an element in a periodic table. So when we work out magnesium, what is A here? What is the value of A? And what about Z? So Z is 12. How many protons are there? Number of protons that is given by Z. So number of protons are 12. Number of neutrons, which is A minus Z. So it will be 24 minus 12 equal to 12. And number of electrons, that is Z minus the charge. So Z is 12 minus charge is 0. That is also 12. When we draw the structure, we have 12 protons and 12 neutrons. I will draw the first shell. Maximum I can have 2 electrons. So out of 12, I have 2 electrons in the first shell. The second shell, maximum I can have 8. So out of 12, when I put 8 electrons here, so means I arrange totally 10 electrons. So 2, 8, make it 10. And then I have to draw the third shell. Third shell maximum can have 18, 8 or 18. So, but I'm only left with 2, so I will arrange 2 electrons. So what is the group number here? Group number represent number of electrons in the last shell. So there are 2 electrons in the last shell, so it is in group 2. And when we write so it is group 2, that's right. And what about electronic configuration? I'm writing in short EC, means electronic configuration. So what will be the electronic configuration of this magnesium atom? It will be 2, 8, 2. And the last shell electron, that is representing the group number. And when you check the periodic table, you can easily find, when you check the magnesium, you can clearly see magnesium here and which group it belongs to. So it belongs to group 2. So without a periodic table, you can also work out the group of the element. And what about, there's also another thing which we call the period, which represent, yes, Saim, what's your question? Which line you're talking about, Saim? The electronic configuration represent the number of electrons arranged in a shell. So in the first shell, we have 2 electrons. In the second shell, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. And in the third shell, we have 2 electrons. So electronic configuration is 2, 8, 2. Yeah, so number of electron is Z minus the charge. Z is 12 here. And because there is no charge on this, you cannot see any charge. So the charge is 0. So 12 minus 0, that is equals to 12. So we have to arrange 12 electron in magnesium. So when we arrange first shell, we arrange 2 electron. Second shell, we arrange 8. And the third shell remaining 2. So the electronic configuration is 2, 8 and 2. Is it clear? Yes, Saim Ahmed. Then we define a period in a periodic table which represent the horizontal rows, also known as, yes, we can also do it without a diagram. So this can be done without a diagram. Without a diagram, how you can work out the group number? So you can simply check, like if I say what is a group of phosphorus, can you work out the group of phosphorus from the periodic table? So you just have to check which column it belongs to. So the column it belongs to, that is known as a group number. So phosphorus belongs to group 5. Whereas in a periodic table, the period represent the horizontal rows, which also shows the total number of shells in an atom. So how many shells are there in an atom we use? That is known as the period. And the horizontal, this is the first period from left to right, then the second period, third period, fourth period, fifth period, sixth period, and seventh period. So there are basically 7 periods in a periodic table. This is first period, second, third, fourth, fifth, sixth, and seventh. And what does it represent? It represents the total number of shells in an atom. How many shells we use in an atom? That is called a period. So example, how many shells are used here in magnesium? How many shells we use to draw the structure of magnesium? So we use 3 shells. This is the first shell, second shell, and third shell. So what is the period of this magnesium? It is in third period. And you can see in a periodic table as we work out magnesium, here we have magnesium. This is magnesium. And when you check the group number, it belongs to group 2. And when you check the period number, this is period 1, period 2, and period 3. So magnesium belongs to third period. It is the third period element and it is second group element. Is it clear? The concept of the group and the period. The period is representing the number of the shells which we use in an atom. Same way, if you want to work out what is the period of beryllium, which period beryllium belongs to? The term period means the total number of shells. So how many shells we use here? So we use 2 shells. This is the first shell and this is the second. So it means it belongs to second period. So beryllium belongs to group 2 and period 2. So when we complete this, work out the position of the beryllium. This is beryllium. When you check the group, so it belongs to group 2 and this is period 1 and this is period 2. So it belongs to group 2 and period 2. So if I say which group sulfur belongs to, which group sulfur belongs to, group number. What is the group for sulfur? So when you check the group, it is group 6. And what about the period? So when you check, this is period 1, 2 and 3. So this is the third period. So sulfur belongs to group 6 and period 3. I'll share another link, less than a minute left, and continue this discussion.